On August 5, 2012, the Mars Science Laboratory made a harrowing descent and successfully landed on Mars. Dr. Robert Downs, professor of mineralogy in the Department of Geosciences at the U of A, describes the sophisticated rover.
Curiosity Rover it's sort of a wagon, okay, about the size of a small car, and it contains a lot of instruments that are going to be used to measure things on Mars. I believe there's 10 instruments total.
Dr. William Boynton of Lunar and Planetary Sciences describes the Curiosity Rover's mission.
It's going to be looking in a very general sense for what Mars habitability might have been like in the past, whether life could have existed.
This is the first time we're using nuclear power in a rover. So now with the nuclear powered engine, we can really ramp up and run energy gobbing instruments. Nothing like that has ever flown in space before.
There's quite a wide range of things that will be studying the geology and geochemistry of the surface. In this case, the U of A didn't build any of the instruments. We do have scientists working with it.
For 2 years, Boynton and Downs are responsible for analyzing data from 2 of the instruments, some of which are so advanced they almost seem to be fictional.
One will shoot a laser and blast the rock like a Star Wars thing, and when it vaporizes the rock, it'll measure the spectra that's emitted from the rock, and that will tell us arm-waving idea of the chemistry of the rock.
Downs describes how the NASA-built instrument called ChemMin will work. Curiosity's robotic arm places rock and soil samples into a chamber inside the rover.
Our instrument is an X-ray diffractometer, and we'll have an X-ray beam that passes through it. And as it vibrates, it will continually rotate and change its orientation, so we will be able to view the grains of sand or rock in all sorts of different relationships, and a pattern will emerge on a detector, a CCD, much like the detector that you use in your cameras to take pictures, except it's taking pictures of the X-rays. We get the absolute identity of what the material is. And there may be telltale minerals that formed due to life.
Dr. Boynton will interpret data from a Russian-built instrument looking for an element thought to be essential to life.
Well, the instrument I'm associated with, it's called DAN. It stands for Dynamic Albedo of Neutrons, which is going to be looking for moisture in the soil, and it actually zaps the surface with a pulse of neutrons, and these neutrons get bounced back to the lander, to the rover, and depending on how much water is present determines how much of these neutrons get bounced back. So that's how we do the prospecting under the surface. U of A's Lunar and Planetary Lab and the Department of Planetary Sciences, we've been doing these Mars missions ever since NASA started going to Mars. We've been involved in every one of them.
Past NASA Mars missions have involved other UA departments. In this case, the Department of Geosciences contributes.
I'm an expert on identifying things. Our lab has looked at more unknown minerals than maybe any lab in the world, and the Mars rover people recognized that we had talents that they didn't have. I didn't plan on being involved with Mars, but now that I am, I'm really excited because that allows me to see more than just detail. I can think big picture.
I'm actually very hopeful that we'll learn lots of interesting things. It looks like a place that could have been hospitable, and if there really were life found elsewhere in the solar system, that would be a really very, very interesting discovery.